The cosmos is teeming with questions for which we currently have no answers. This audio course delves into the most significant mysteries that science has yet to solve, spanning from the dawn of time to the very essence of consciousness. While these inquiries might appear straightforward, they are so profound that their solutions could completely reshape what you think you know about reality. Science is an expedition filled with unresolved puzzles, a voyage that guides us directly into the unknown. Every part of our universe presents enigmas that compel us to investigate and explore more deeply. Consider dark matter, for instance. Even though you cannot see or touch it, we have determined that it constitutes about 27% of the cosmos. Think of it as a colossal jigsaw puzzle where the vast majority of pieces are kept out of sight. That is dark matter, an essential component of the cosmic picture we have not yet managed to piece together. Then you have dark energy, which stands as another of the universe's great conundrums. Are you aware that this mystifying force is actually causing the expansion of the universe to accelerate? It is almost as if the cosmos possesses a concealed engine, driving it to expand at an ever-increasing rate. The question remains, why? We are still searching for the mechanisms behind this accelerated expansion, and each attempt to find them seems to only generate more questions. As you gaze beyond the stars, you encounter the fascinating architecture of the universe itself. Why is it arranged in such a distinct pattern? From the elegant spirals of galaxies to the vast clusters they form, the cosmos seems to adhere to a specific design, resembling an immense tapestry woven from the threads of matter and energy. What elemental forces were responsible for sculpting this grand structure? The assembly of these large-scale formations is a puzzle that invites you to explore the very history of the universe. Speaking of cosmic history, it is impossible to ignore the challenge of quantum gravity. You see, the principles that apply to extremely large objects like planets and galaxies are different from the laws that dictate the behavior of the incredibly small, such as subatomic particles. Can you envision a reality where these two sets of rules could finally converge and work in harmony? The absence of a single, unified theory that marries gravity with quantum mechanics continues to be a persistent challenge that troubles many scientists. We must also remember the one question that has captivated humanity for ages. Are you and I alone in the universe? The potential for life beyond Earth not only ignites your curiosity, but also forces a deeper reflection upon your own place in the cosmos. What is the significance of being human in a universe of this scale? Could there be other beings out there, looking up at their stars with the same sense of awe that we feel? Time presents another factual, conceptual puzzle. What fundamentally is time? Is it a linear progression that moves unceasingly into the future? Or could it be a phenomenon of far greater complexity? The true nature of time continues to be one of the most profound questions you can contemplate. Considering its essence compels you to ask whether we genuinely inhabit a universe where the past, present, and future are as distinct as they appear to be. Next, there's the Big Bang Theory, which offers our best explanation for the universe's origins. But what could have preceded this colossal event? The potential answers are as captivating as they are bewildering. For many, the concept of a whole universe materializing out of nothing is challenging to accept. Yet this idea serves as the very bedrock of how we currently understand our own existence. As you venture further into the core of cosmic inquiry, you come across the enthralling theory of the multiverse. What if our universe is not the only one, and countless others exist, each governed by its own unique set of physical laws and realities? This notion fundamentally challenges your perception of existence and brings up deep philosophical quandaries. What does it mean for you to be a part of this universe, if it is just one small piece of a much grander reality? Black holes, those profoundly strange and powerful cosmic features, are another source of immense fascination. What secrets are hidden inside of them? Perhaps by understanding their internal mechanics, you could unlock fundamental truths about the nature of matter and energy. Every black hole represents a portal to the unknown, a place where the laws of physics as you understand them simply seem to break down. The cosmological constant, a concept that has made a significant comeback in modern cosmic study, also requires your attention. What exact function does it serve in the universe's evolution? This constant seems to be a common thread that connects many of the greatest questions in cosmology, and comprehending it could be the very key to solving other outstanding mysteries. Perhaps the most fundamental question of all is why there is something instead of nothing. This question forces you to reflect on your own existence and your position within the cosmos. The answers might lie in philosophy, science, or some fusion of the two, but every effort to tackle this question brings you a step closer to understanding what it means to be. Our understanding of the universe is also deeply connected to the nature of consciousness itself. How does your subjective perception of reality relate to the immense cosmos that surrounds you? Human consciousness remains a highly complex phenomenon that defies easy explanation and raises questions about the very definition of life. Finally, the field of quantum information is increasingly becoming a central topic in discussions about the universe. What is the implication of information being a fundamental building block of reality? The notion that information could be just as crucial as matter and energy is forcing you to completely reevaluate your understanding of the cosmos on a foundational level. As you explore these inquiries, you discover that each solution only gives rise to new questions. This pursuit of knowledge is a never-ending cycle, with every discovery propelling you deeper into the mystery. For example, dark matter, one of the universe's most profound enigmas, may sound like an idea straight out of a science fiction story. However, its existence is a scientific reality, comprising approximately 27% of everything in our cosmos. But what is it? And why has it been so difficult for you to find? To begin to grasp this, first think about how you typically observe the universe. When you look into the night sky, your eyes perceive stars, planets, and entire galaxies. But what you are seeing is nowhere near the full picture. In reality, all the visible matter that you can actually detect and measure accounts for just a tiny portion of the universe's total mass. The remaining, enigmatic portion of the cosmos is what we call dark matter, a substance that fails to produce, take in, or bounce back any light. This characteristic renders it fundamentally invisible to our instruments, making its presence a profound puzzle. So, you might ask, how can we be certain it's there at all? The evidence comes from observing the way galaxies spin. When we look at a galaxy, such as our own Milky Way, we find that stars at its edges are moving with incredible velocity, so fast that gravity should have flung them off into deep space. The fact that they remain in orbit implies the existence of an enormous amount of invisible mass, an unseen gravitational anchor we identify as dark matter. To help you visualize this, picture yourself at a park, watching friends play with a ball that seems to move on its own. While you can't see who's pulling the string that dictates its path, you can deduce their presence from the ball's motion. Dark matter functions similarly throughout the universe. Though we cannot observe it directly, we feel its influence through the interactions of galaxies and other cosmic objects. One of the most astonishing things about dark matter is that, unlike everything we are familiar with, it is not composed of atoms. It's as if the universe is built with secret ingredients that our current technology is unable to analyze. Some physicists theorize it could be made of particles known as WIMPs, or weakly interacting massive particles. But to this day, these particles have proven as elusive as phantoms in a fog. The mystery deepens when we consider that dark matter also seems to guide the formation of the universe's large-scale structures. Galaxies are not scattered randomly across space. They are arranged along immense filaments of dark matter, forming a vast cosmic web. You can think of this as being similar to how currents in a river carve out the landscape around it. Without dark matter, the cosmos we observe today would look completely different, with far fewer galaxies and an entirely different stellar layout. But why has it been impossible for us to detect it directly? The answer is embedded in its very essence. Since dark matter does not engage with light in any way, our instruments are blind to it. Scientists have built experiments deep underground, shielded from the interference of light and radiation, yet dark matter has consistently avoided being captured. The search feels like a cosmic game of hide-and-seek where one player is perfectly invisible. In response, some researchers are now exploring alternative methods, such as studying its effects on the cosmic microwave background, the faint radiation left over from the Big Bang. By analyzing minute fluctuations in this ancient afterglow, scientists aim to learn more about dark matter's properties. However, as with any great scientific puzzle, every new piece of information we find seems to introduce even more profound questions. The search for dark matter is a journey filled with mysteries and theories. Some even speculate whether there are other forms of life in the universe also grappling with this phenomenon. Perhaps, in a remote corner of the galaxy, an advanced civilization is debating the very same dark matter that intrigues us. As our understanding advances, philosophical questions about our perception of reality naturally arise. If dark matter constitutes the majority of the universe, what does that imply about how we see things? Are we viewing the cosmos as it truly is, or only a minuscule fraction of its actual substance? Every potential answer seems to open a door to new enigmas. Dark matter is more than just a scientific problem. It's a testament to human curiosity that challenges us to explore the unknown, question our perceptions, and seek answers in a universe that consistently remains just beyond our grasp. As we press forward with our investigations, we are reminded that each new discovery is just another stepping stone in our grand quest to comprehend the vast and wondrous cosmos we inhabit. In conclusion, dark matter serves as a powerful reminder that while we may think we know the universe, we are merely on the edge of a tremendous ocean of mysteries. Every question we ask opens new doors and reveals new paths to the truth. So, as we continue to explore, let us keep an open mind and a curious spirit, because the universe offers far more than our eyes can see. Dark energy represents one of the most compelling riddles of the cosmos. But do we truly have any idea what it is? To begin to understand it, let's first consider the behavior of the universe itself. For a long time, astronomers operated under the assumption that the universe was expanding. But a discovery in 1998 was absolutely astonishing. The universe is not only getting bigger, it is doing so at a continuously accelerating pace. What kind of force could possibly be driving galaxies apart from one another with such increasing vigor? Imagine you are inflating a balloon. As more air fills it, the balloon's surface stretches, causing dots drawn upon it to move farther apart. Now, what if, instead of just a steady inflation, the balloon started to expand faster and faster, making the dots recede at an ever-increasing speed? This is the very phenomenon we witness in the cosmos, and the driver behind this acceleration is what we have termed dark energy. As scientists have delved deeper into this puzzle, they have determined that dark energy makes up about 68% of the entire universe. But here we arrive at the central question. Where does it originate? It feels as if we're attempting to solve a puzzle with most of the pieces missing. Although we are certain dark energy exists because we can observe its effects, its fundamental nature continues to be a profound mystery. One of the most prevalent theories posits that dark energy is an inherent property of space itself. From this perspective, you could conceive of space as a kind of field that expands as the universe does. But if this is the case, what does that mean for our comprehension of the universe? It would suggest that space itself is physically pushing galaxies apart, creating a repulsive force that defies gravity, which normally pulls everything together. You might then wonder why we don't observe this effect in our daily lives. The answer lies in the matter of scale. Gravity, the force that keeps planets in their orbits and pulls objects toward the Earth, is overwhelmingly stronger than dark energy on a small scale. However, when you look at cosmological scales, across the vast expanse of the universe, this energy becomes the most dominant force in play. What if dark energy is not just a component of the universe, but rather a manifestation of something even more fundamental? Some researchers have proposed a potential connection between dark energy and either Einstein's theory of relativity or elements of quantum physics. This line of thought introduces a host of fascinating possibilities. For example, is it conceivable that dark energy serves as evidence for extra dimensions that lie beyond our perception? When I contemplate this, I find it impossible not to experience a blend of awe and frustration. We are certain that dark energy is real, yet its fundamentally elusive quality compels us to re-examine our most basic theories and models. Trying to understand it feels like attempting to capture smoke in your hands. Just when you believe you have a hold on it, it slips away. Moreover, the investigation into dark energy inevitably brings us to consider its relationship with dark matter, another predominant yet unseen component of the cosmos. Although both substances are invisible and mysterious, their behaviors are starkly different. Dark matter functions like a cosmic adhesive, binding galaxies and their larger structures, whereas dark energy produces the opposite outcome by driving everything apart. The effort to comprehend dark energy also forces us to rethink our expectations for the universe's ultimate fate. Should the accelerated expansion persist, we might be heading toward a future where galaxies are so distant from one another that they vanish from view entirely. This scenario introduces profound questions about the very essence of time and existence. A further captivating element is how dark energy defies our current understanding of fundamental forces. Our models of physics are built upon gravity, electromagnetism, and the nuclear forces. But dark energy doesn't align with any of these established categories. It's possible that we are on the brink of identifying a completely new force of nature. As scientists press forward with their investigations, they employ massive telescopes and sophisticated experiments to unravel this cosmic puzzle. Every new observation confirming the universe's accelerating expansion moves us incrementally closer to the answers we have sought for so long. However, each discovery often generates even more complex questions, perpetuating an endless cycle of inquiry. Dark energy is more than just a constituent of the cosmos. It embodies our own unyielding search for knowledge. It serves as a powerful reminder that, for all our advancements, innumerable mysteries are still out there, waiting for us to uncover them. Within this immense universe, dark energy could be the very key that unlocks not just cosmic expansion, but the fundamental fabric of reality we inhabit. Ultimately, dark energy highlights the fact that in the scientific journey, what remains unknown can be every bit as compelling as what we have already charted. It beckons us to continue our exploration, to persist in asking questions, and most importantly, to never lose our sense of wonder at the vast and enigmatic cosmos that envelops us. The immense emptiness of the universe is not merely a sight to behold. It's a deeply intriguing enigma. But have you ever stopped to consider why the cosmos possesses such a peculiar structure? There is something truly remarkable about the distribution of everything, from the magnificent galaxies pirouetting through space to the star clusters woven into a complex tapestry. To grasp the structure of the universe, one approach is to think of it as an enormous textile. Imagine a canvas woven from threads of varying colors and densities, where each strand represents a galaxy. The pattern they form tells the story of the universe's history. While everything began in a state of chaos, gravity eventually emerged as the primary organizing thread, acting like a powerful magnet that pulls matter into concentrated formations. Instead of being scattered randomly, galaxies are arranged in structures that look like colossal filaments. But what dictates why these clusters form in some regions and not others? The solution seems to involve dark matter, that enigmatic substance we cannot observe directly, but whose gravitational influence is immense. You can picture dark matter as an unseen cosmic web that supports and directs galaxies, carving out pathways through space for them to follow and merge into greater structures. In the nascent universe, minuscule fluctuations in the density of matter provided the seeds for these formations. As the cosmos expanded, these slight initial differences were magnified. Areas with slightly more matter developed stronger gravitational fields, which in turn attracted even more material. This process is what led to the birth of the first stars and galaxies, which later congregated into clusters and superclusters. Imagine a cosmic party where every guest is a galaxy. At first, they all drift about without direction, but as the music of gravity begins to play, some start gathering into groups. Over time, these groups evolve into vast families of galaxies, all interconnected by that gravitational rhythm. This is how the orderly structures we observe today were born from primordial disarray. Galaxy clusters are like archipelagos in a dark cosmic ocean, with each one containing hundreds or even thousands of galaxies bound by their collective gravity. So why don't they simply fly apart into the void? The answer appears to be a delicate equilibrium between the pull of gravity and the push of dark energy, a force that drives the universe's accelerated expansion, creating a cosmic dance of attraction and repulsion. The filaments of dark matter are also essential to this grand architecture, functioning as a kind of intergalactic skeleton that guides galaxies. You could think of these filaments as highways on a cosmic map, with galaxies traveling along routes defined by gravity. Without the influence of dark matter, a great many of these magnificent structures would likely not exist at all. So how do these structures change throughout cosmic history? As the universe's expansion continues, galaxy clusters also persist in their growth, occasionally colliding and merging to form even newer, larger structures. This is a dynamic and unending process where galaxies journey through space, sometimes crashing together in a celestial spectacle that sparks the formation of new stars and solar systems. Finally, understanding the structure of the universe prompts us to reflect on our own position within it. If the cosmos is truly a vast ocean of galaxies, you have to wonder, where exactly do we fit into this incredible picture? In the boundless theater of space, Earth is merely a tiny blue point of light. Yet, every insight we gain about the universe's vast structures brings us closer to understanding our own place within it. To grasp how these cosmic architectures formed and evolved, researchers often utilize computer simulations. These models allow them to observe the interaction between dark matter and gravity, essentially rewinding time to witness the universe in its chaotic infancy. As we persist in our exploration of the cosmos, new puzzles continuously emerge, such as what undiscovered structures might exist, and how future findings will alter our comprehension of dark matter and dark energy. Every solution we uncover simply unlocks a new set of mysteries, compelling us to press onward into the unknown. The universe's structure is a living record of its past, a monument to the forces that sculpted our reality. Every galaxy, cluster, and filament of dark matter narrates a history that extends far beyond our visual grasp. By investigating these formations, we are not only decoding the universe's secrets, but also searching for our own position within this grand design. The real question is whether you are prepared to continue this voyage of discovery, as the choice ultimately rests with us. Let's consider what happens when you attempt to reconcile two of the most influential theories in modern physics: gravity and quantum mechanics. This conundrum, referred to as the quantum gravity dilemma, embarks us on a captivating exploration of the universe's most profound secrets. At the macroscopic level, gravity dictates the motion of planets, stars, and galaxies. But in the microscopic world of subatomic particles, quantum mechanics holds sway. The critical issue is what occurs when these two forces clash. Gravity explains the attraction between objects with mass. For example, if you're at a park and watch a friend toss a ball, gravity is the force that inevitably pulls it back to the ground. However, upon examining reality at the particle level, the rules of quantum mechanics apply. Here, particles don't act like predictable solid objects. Instead, they exist as clouds of probability, making it impossible to know their exact location at any given moment. So, what makes uniting these two theories such a formidable task? An analogy might clarify the issue. Imagine gravity as a detailed roadmap, and quantum mechanics as a swarm of chaotic bicycles in a crowded city. While the map provides clear directions to a destination, the bicycles move unpredictably, adhering to no obvious rules. The core difficulty is that these two frameworks lack a common language to communicate effectively. Efforts to merge gravity and quantum mechanics have pushed physicists to investigate unconventional ideas, including string theory and the existence of extra dimensions. String theory proposes that everything in the cosmos is composed not of point-like particles, but of minuscule vibrating strings. This, however, introduces a new puzzle. What might exist beyond the dimensions we currently perceive? Are we truly confined to a reality of just 3 spatial dimensions and 1 of time? Black holes represent another arena where this theoretical discord becomes especially clear. At the center of a black hole, the force of gravity is so immense that nothing, not even light, can break free. Quantum mechanics insists that information can never be destroyed, yet gravitational theory implies that whatever enters a black hole is permanently erased. This paradox has fueled intense discussion, since the destruction of information would defy the foundational tenets of physics. This entire dilemma prompts an exciting question. Could a new form of physics exist that unifies these two separate worlds? Some theorists have put forward the concept that gravity is not a force, but rather a consequence of the geometry of space-time itself. In this interpretation, space-time acts like a flexible fabric that bends under the weight of massive objects. This elegant picture, however, becomes profoundly more complex when you try to integrate the principles of quantum mechanics. The quest for a quantum theory of gravity is more than just an intellectual exercise. It carries deep philosophical implications. If we could successfully understand how gravity and quantum mechanics operate in unison, we might discover entirely new ways of thinking about space, time, and the nature of reality. Imagine what that could mean for your perception of the universe and your role within it. Some scientists have even speculated that quantum gravity could revolutionize our understanding of consciousness. If all elements of the universe are interconnected through these fundamental forces, perhaps our own awareness is woven into a much larger cosmic fabric. While highly speculative, this notion opens up a fresh perspective on the relationship between humanity and the cosmos. It also forces us to question the very fabric of reality. If our perceptions are just an emergent property of quantum interactions, what is actually real? As researchers persist in their pursuit of a unified theory, the quantum gravity dilemma stands as one of the great unsolved mysteries in science. While delving into these concepts, you realize that each answer we find only gives rise to more profound questions. This journey is not just about comprehending the universe, it's also about understanding ourselves. Human curiosity is a relentless force, and even though we may never unravel every cosmic secret, each discovery edges us incrementally closer to the truth. So, as we continue to probe the intricacies of quantum gravity, let's remember that every question is an invitation to keep exploring, dreaming, and investigating the vast and fascinating universe that envelops us. The search for life beyond Earth is one of the grandest adventures in science, a subject that inspires both immense curiosity and a sense of wonder. We frequently ask ourselves if we are alone in this universe, and its sheer scale suggests the answer is likely no. And yet, to this day, we have not found a single piece of definitive evidence for life anywhere else. Let's start by picturing the cosmos as an immense, uncharted sea, where our planet Earth is merely a single, small island. When you consider that our galaxy contains billions of stars, each with the potential for its own family of planets, the sheer quantity of possibly life-sustaining worlds is simply staggering. So why, then, have we yet to discover any evidence of life beyond our own? A compelling possibility is that life as we understand it is an incredibly uncommon phenomenon. The precise mix of circumstances required for life to emerge and evolve is exceptionally specific, with variables like suitable temperatures, the existence of liquid water, and a sheltering atmosphere all needing to fall into place perfectly. It could be that while innumerable worlds could theoretically harbor life, Earth represents a truly extraordinary anomaly. Conversely, another school of thought suggests that life may exist in forms that we are currently unable to recognize. What if extraterrestrial beings are not built upon a carbon-based chemistry like us, but on entirely different elements? You can envision organisms that have adapted to thrive in profoundly alien settings, such as the depths of a methane ocean, or on planets with atmospheres completely unlike ours. The breathtaking variety of life on Earth alone makes the prospect of even more exotic life forms elsewhere in the universe a truly thrilling idea. In this great search, one of the most widely adopted strategies has been to scan for radio signals from technologically advanced societies. Initiatives such as the Search for Extraterrestrial Intelligence, or SETI, dedicate resources to listening for such broadcasts from the cosmos. But this raises a crucial question. What if intelligent civilizations have moved beyond radio technology? They may be using methods of communication that we have not yet even begun to theorize, making our search akin to trying to follow a conversation spoken in a completely foreign tongue. The Fermi paradox introduces another layer of complexity to our quest. It poses a fundamental contradiction. If the universe is filled with countless stars and planets where life could likely arise, why have we found no trace of it? One sobering explanation is that advanced cultures have a tendency to annihilate themselves before they achieve interstellar travel. It is a humbling thought that we might be at a similar turning point in our own history. facing a choice about our collective destiny. Another critical element you must account for is the sheer immensity of cosmic time. The universe has been around for billions of years, whereas life on Earth has occupied only a tiny fraction of that timeline. It is entirely plausible that advanced societies existed in other epochs of the universe's history, only to perish long before we had the means to detect them. This scenario is much like trying to hear a specific song at a festival, where different bands are scheduled to play at completely different times. Our exploratory efforts have also focused on our immediate cosmic neighborhood. Worlds such as Mars and Jupiter's moon Europa and Saturn's moon Enceladus are primary targets in our hunt for life. These locations fascinate us because they show evidence of harboring liquid water, which is the one ingredient we consider indispensable for life. Discovering even microscopic organisms in these places would represent a truly monumental breakthrough for humanity. Moreover, the definition of life in our search is not strictly confined to biological organisms. With the rapid progress in artificial intelligence and robotics, some scientists propose that we could engineer new types of artificial life designed to explore the cosmos on our behalf. It is conceivable that the entire future of space exploration may ultimately rest on these non-biological successors. The question of our solitude in the universe also carries deep philosophical weight. Should we ever find extraterrestrial life, even in its most basic form, it would forever alter how we perceive our own significance in the cosmos. Such a discovery would compel us to re-examine our most fundamental beliefs about humanity, spirituality, and our overall connection to the universe. Ultimately, it is crucial to recognize that the search for extraterrestrial life is not solely about discovering other civilizations. This endeavor is equally a journey to better comprehend our own existence, allowing us to investigate our past and contemplate our future. Every new finding and every fresh question moves us closer to solving the mystery of our purpose and what it signifies to be human in such a vast expanse. And so, as you and I continue to look up at the stars, the fundamental question persists. Are we truly alone? The answer might be concealed in the deepest reaches of space, patiently awaiting discovery. In the meantime, the quest itself, with all its wonder and uncertainty, is an odyssey that is profoundly worth undertaking. The very essence of time is an enigma that has captivated philosophers, scientists, and thinkers across all of human history. Ever since our ancestors first gazed at the night sky, we have strived to grasp not only the mechanics of the universe, but also its relationship with the flow of time. It is remarkable that although every one of us feels time's relentless passage, its fundamental nature remains an unsolved puzzle. To begin exploring this puzzle, it helps to visualize time as a great river. We are carried along its current, sensing it sweep away the moments that are gone and propel us toward what is to come. However, this metaphorical river might not be as straightforward as it appears. Is time a linear path that travels directly from the past into the future, or could it be a far more elaborate structure? Modern physics, especially Albert Einstein's theory of relativity, suggests that time can act in truly surprising ways that are dependent on your velocity and the gravitational forces around you. A particularly engrossing aspect of this is time's intimate link to space. The notion that time and space are woven together into a single four-dimensional fabric is a truly compelling concept. Within this framework, time is not some simple clockwork device measuring out seconds and minutes, but rather a full-fledged dimension capable of being bent and stretched. This flexibility means that time's pace can actually change, running faster or slower under various conditions. For instance, a clock on Earth would measure time differently than one positioned near a black hole, where the immense gravity would profoundly distort its rhythm. As you delve into the nature of time, fascinating possibilities emerge, such as whether it is feasible to journey into the past. While countless works of science fiction have explored this very idea, the laws of physics indicate that traveling backward through time presents a challenge of extraordinary and perhaps insurmountable complexity. The potential for paradoxes, like the well-known grandfather paradox, casts serious doubt on the very idea of traveling to the past. If you were able to alter historical events, you have to wonder what consequences those changes would have for your present reality. Traveling to the future, however, appears much more plausible, though it comes with its own set of profound challenges, raising the question of whether our future is a set of possibilities we create or simply an unfolding of a predetermined script. The age-old debate between determinism and free will lies at the heart of this dilemma. If your future is already written, you are forced to question the authenticity of your own choices. Are you truly in control of your decisions, or are you merely an actor following a preordained narrative, with every action and thought already laid out for you? It is also essential to consider your own subjective experience of time's passage. Moments of happiness can seem to vanish in an instant, whereas periods of suffering feel like they stretch on for an eternity. Research indicates that our memory is a major factor in this phenomenon, as we tend to recall significant events with such vividness that they create the illusion of having lasted far longer than they actually did. An even more perplexing idea is that time might not be a straight line at all. Certain theories propose a cyclical model of time, envisioning it as a loop that repeats endlessly. In this framework, the past, present, and future are not distinct segments but are instead interwoven parts of the same continuous, repeating cycle, an idea that has found echoes in many cultures and philosophies throughout human history. Furthermore, a deep connection might exist between time and your consciousness itself. Have you ever considered if your perception of time is just a construction of your mind? When you are completely absorbed in an activity, time can seem to fade away. Yet during moments of intense anxiety, each second can feel agonizingly long. This link between your internal state and external time provokes deep questions about the fundamental nature of reality. Quantum physics introduces yet another level of intricacy to our concept of time. Within the quantum realm, particles can exist in a state of superposition, which allows them to be in multiple locations simultaneously. This bizarre property forces us to reconsider the relationship between time and space at the universe's most fundamental level. If time itself could be an illusion, then you must ask what else we think we know about reality is also open to question. When you take all of this into account, it becomes evident that time is a concept far more complex than the numbers on a clock face. It is an intricate construct that shapes your daily existence, your thinking, and your entire grasp of the cosmos. The way you perceive time can vary as widely as human experience itself. Some cultures envision time as cyclical, while others see it as a linear path moving relentlessly forward. As you delve deeper into these ideas, the fundamental question persists: what is time, really? We may never find a single definitive answer, but the very act of this exploration is crucial to understanding our universe. Questioning the nature of time prompts you to reflect on your own existence, your choices, and your connection to the world, turning the search for answers about time into a search for meaning in your own life. Have you ever contemplated the origins of our universe? It all began with the Big Bang, an immense and enigmatic explosion of energy and matter. The question that has captivated scientists and philosophers for generations is what exactly occurred in the instant before that definitive moment. Some theories propose that before the Big Bang, the concepts of time and space as you and I understand them simply did not exist. To grasp this mind-bending concept, it helps to visualize a balloon. As you inflate it, its surface expands, causing all the points on that surface to move farther apart. In this analogy, the Big Bang represents the moment the inflation begins. Prior to this, you might imagine there was no surface, no space, and no time. Just a singularity, a point of almost infinite density and temperature. But what if that point was a seed, brimming with the potential to grow into something magnificent? Contemporary scientific models suggest that, in its earliest fractions of a second, the universe expanded at an unbelievable speed, in a process known as cosmic inflation. This expansion was likely driven by an inflationary field, yet the precise nature of this phenomenon remains a mystery. What was the source of its energy? Where did it originate? And where did it ultimately go? These questions force you to contemplate the deepest fabric of the universe itself. From that incomprehensibly tiny point, a universe of astounding complexity emerged, containing all the galaxies, stars, and planets we know today. Some scientists theorize that this process may not have been a singular event. They propose that the universe could be cyclical, undergoing endless phases of contraction and expansion. This leads you to wonder if the Big Bang was not a true beginning, but merely one stage in a perpetual cosmic cycle. This line of inquiry naturally leads to another profound question about the fate of the universe. If it had such a dramatic start, how will it eventually end? Some cosmologists believe it will continue expanding forever, becoming cold and empty, while others speculate it might one day collapse back in on itself in a big crunch. You can imagine a grand cycle of cosmic birth, death, and rebirth, where the universe continually resets itself. Ultimately, this brings us to the most fundamental philosophical questions about our own place within this vast cosmos. As you contemplate the nature of existence, you arrive at the ultimate query. Why is there something instead of nothing? This question has perplexed thinkers for millennia. Some argue that the universe is merely the outcome of physical laws and random probability, while others contend that there is a deeper, underlying purpose. The true answer remains one of humanity's greatest, enduring mysteries. The Big Bang Theory inevitably pushes us to ask fundamental questions regarding matter and energy. The substance and force we recognize today were forged in that initial cosmic explosion, which begs the question of what came before. If you consider that matter and energy are two sides of the same coin, it's possible they didn't exist in any form we can comprehend. A thought that unlocks a vast realm of new possibilities. Let's discuss the cosmic microwave background, which is a faint, pervasive glow throughout the cosmos that serves as a tangible artifact of the Big Bang. Whenever you gaze into the night sky, you are looking at the afterglow of that creation event. But what is it truly communicating to us? Many researchers contend that this radiation holds vital clues to the universe's structure and its developmental history, yet a great many of its secrets remain locked away. Our journey to comprehend the Big Bang also steers us into the domain of quantum physics. On the most minuscule scales, particles defy our conventional expectations, existing instead as fields of probability, and forcing us to reconsider the nature of reality. Is the cosmos a predictable clockwork mechanism, or is its fate ultimately decided by chance? It is this profound duality that makes the intersection of science and philosophy so compelling. As our comprehension of the cosmos deepens, our innate human curiosity only grows stronger. Probing the secrets of the Big Bang is merely a single chapter in a far grander narrative of exploration. Each new finding seems to generate more questions, and every solution we find only reveals another door to be opened. you have to wonder what cosmic enigma we are destined to unravel next on this epic journey. When we contemplate the Big Bang and its origins, it's essential to recognize that we are participants in a continuing odyssey. From the inquisitive spark that prompts our questions to the breakthroughs that draw us nearer to the truth, every single step holds significance. Investigating the universe is a perpetual quest that calls on us to question, to discover, and to stand in awe of our boundless existence. So, when you look up at the stars, know that each point of light is a distant echo of that first instant, reminding you that so much more awaits discovery. Is it possible that other universes exist? This query stands as one of the most captivating puzzles that scientists and philosophers have wrestled with over the centuries. The notion that our own cosmos could be just one among an untold number of others is simultaneously thrilling and staggering. To grasp this, you must examine the concept of the multiverse, a hypothesis proposing a vast collection of universes, each governed by its own distinct physical laws and possessing its own unique properties. The idea of a multiverse might seem like pure speculation, but it's actually rooted in legitimate scientific theories. For instance, string theory, which aims to be a unified explanation for all of nature's fundamental forces, suggests the presence of dimensions beyond the three we experience. These extra dimensions could easily house entirely separate universes, where fundamental constants are different, and the principles of matter and energy operate in unfamiliar ways. Just try to picture a universe where gravity is too feeble for planets to coalesce, or another where the speed of light is not what we know it to be. The possibilities are virtually limitless. So, how did we even arrive at the hypothesis that other universes could be real? A significant clue comes from the theory of cosmic inflation, a period of exponential growth thought to have occurred moments after the Big Bang. During this phase, the universe expanded at an unbelievable speed, much like a rapidly inflating balloon. Some physicists theorize that this inflationary event wasn't unique, but rather could be happening continuously, creating distinct bubbles of space-time that evolve into independent universes. In this model, our universe is but one bubble floating in a vast cosmic foam. Consider a garden blooming with countless varieties of flowers, where each blossom represents a unique universe with its own form, color, and scent. While some flowers might share similarities, others could be radically different. This vision of a diverse cosmic garden naturally leads you to wonder if we could ever interact with these other realms. The simple answer, for now, is that we have no evidence to suggest we can, though this doesn't entirely rule out the chance that they might influence our own universe in subtle ways. This leads to the unavoidable question: how can we be certain these other universes are actually there? The truth is, for the most part, we can't be. The multiverse concept is incredibly challenging to verify because, by their very nature, these universes are disconnected from ours, making direct observation impossible. However, some scientists are devising experiments that could offer indirect evidence, such as searching for anomalies in the cosmic microwave background that might be scars from a past collision between our universe and another. The multiverse also presents profound philosophical dilemmas. If an infinite number of universes exist, what does that imply about your personal choices and your life story? It suggests that in other cosmoses, alternate versions of you may have made different decisions, resulting in completely different outcomes. This can feel both liberating and deeply unsettling, as the knowledge that a universe exists where you took a different path forces you to reevaluate the very essence of your reality. Some skeptics contend that the multiverse theory ventures outside the proper bounds of science. Their argument is that if these other universes can't be observed or measured, the idea belongs more to metaphysics than to physics. On the other hand, many scientists maintain that progress often requires exploring concepts that are not yet directly testable. For them, the multiverse theory could represent a critical stepping stone toward a more complete understanding of reality as a whole. Ultimately, contemplating the existence of multiple universes compels us to reflect on our own place in the grand scheme of things. What does it truly mean to be human within such an immense and intricate cosmos? If other universes are real, they might host other forms of life and other consciousnesses living out different realities. This thought could foster a sense of cosmic connection that transcends our known world, suggesting the isolation we sometimes feel is merely an illusion, and that we are all part of a much larger tapestry of existence. As our science advances, so too will the depth of our questions. With every new advance in physics and cosmology, fresh questions emerge about whether our reality is part of a multiverse. You might wonder if we could ever develop a method to observe these other universes, or at least uncover firm evidence that they exist. While this may seem like an incredibly remote possibility today, the history of science is filled with surprises where the impossible eventually became fact. This search for the truth about the multiverse is much more than a detached academic exercise. It is a profound journey that challenges our very understanding of reality and our place within it. It represents a distinctly human quest to figure out our position in the cosmos. I believe curiosity is one of the most powerful forces that drives us to explore, to pose difficult questions, and ultimately, to learn. Each time we ask a question about the nature of the universe, we inch a little closer to answers that have the potential to redefine our conception of existence itself. The idea that we might live in a multiverse challenges our most fundamental notions of life, reality, and connection. It invites you to dream bigger and consider the possibility that there is far more to reality than what we can see, and that somewhere within the vast ocean of universes, we might find answers to humanity's deepest questions. The fascination with black holes extends far beyond the realm of science, evoking a sense of profound mystery that captivates almost everyone's imagination. For years, scientists have tried to solve the puzzle of what truly happens inside one of these enigmatic cosmic objects. And while there are numerous theories, the answer remains as difficult to grasp as a whisper on the wind. Black holes are formed when a star of immense mass depletes its nuclear fuel and collapses under its own gravitational force, creating a region of space from which nothing, not even light, can escape. You can picture it as being similar to a whirlpool. Just as water accelerates as it spirals toward the drain, matter speeds up as it approaches a black hole, forming a disk that swirls around it and emits tremendous amounts of radiation, which is how we are able to observe them indirectly. One of the most intriguing questions is what one would experience when crossing the event horizon, the boundary that signifies the point of no return. To an outside observer, time for any object approaching this threshold would appear to slow down dramatically, as its emitted light stretches, a phenomenon we call redshift. Yet for a traveler passing through that horizon, time would continue to flow normally, raising the possibility that they might be entering an entirely different dimension. At the very core of a black hole lies another fascinating concept, the singularity, a point where the laws of physics as we understand them completely break down. A singularity is a location where density becomes infinite and space-time curves to an extreme degree. To better visualize this, you can imagine space as a sheet of paper. Placing a heavy object in its center causes the sheet to bend. A singularity is like that weight, but taken to a level that defies all comprehension. But what if you could actually observe what lies inside? Some theories propose the existence of a bridge to another universe, or even to another point in time, known as a wormhole, a sort of tunnel through space-time. Although wormholes are purely theoretical at this stage, their confirmation would radically alter our entire perception of the universe. Black holes also seem to play a vital part in the evolution of galaxies. It is believed that supermassive black holes, which can possess masses millions or even billions of times greater than our Sun, are located at the centers of most galaxies. Their powerful gravitational influence could be intrinsically linked to the formation and behavior of those galaxies, potentially making these mysterious objects the architects of our cosmos. Another captivating idea is Hawking radiation, which was proposed by the physicist Stephen Hawking. This theory suggests that black holes are not perfectly black. Through a quantum process, they can emit particles and gradually lose mass over enormous spans of time. This implies that, while they seem eternal, black holes may, in fact, eventually evaporate and vanish, suggesting that even they have an end. As we learn more about black holes, we are confronted with deep philosophical questions. What does it even mean to exist in a place where the fundamental rules of reality are called into question? Some scientists theorize that black holes might contain information about the universe in forms we don't yet understand. And the notion that information could be preserved on the event horizon challenges the very nature of reality itself. The possibility that black holes are portals to other universes or dimensions opens up a wide array of speculation. Could we, in theory, travel through them? While this is still just a concept, science fiction has explored these possibilities at length, transporting our imagination to places where conventional physics has not yet dared to go. Our direct observations of black holes have advanced significantly in recent years. With modern telescopes and technology, we have finally been able to see their effects on the surrounding environment. The first ever image of the black hole at the heart of the M87 galaxy was a monumental achievement, showing the world that these entities are not merely theoretical constructs, but cosmic realities. And it only fuels our curiosity about what else we might discover. Black holes constantly remind us that the universe is teeming with mysteries, and every answer we manage to find only gives rise to new questions. As science progresses, it is almost certain that we will continue to uncover more secrets about these incredibly fascinating phenomena. Investigating black holes is a crucial endeavor not only for physicists. It also encourages all of us to consider our own position within the cosmos. Black holes serve as potent symbols of the universe's intricacy and marvel, pushing us to envision beyond our current knowledge and to concede that some truths remain beyond our grasp. While science provides us with fragments of understanding, the universe's deepest mysteries are often concealed within the unknown, prompting us to ask what other marvels await in the cosmic expanse as we contemplate what lies within a black hole. The cosmological constant is a notion that captivates both scientific and philosophical minds alike, forcing us to re-examine the fundamental nature of reality. To grasp this force that appears to guide the universe's expansion, you can visualize the cosmos as an enormous inflating balloon. As it inflates, every point on its surface recedes from every other point, a process that mirrors the way galaxies are currently moving away from one another across space. So, what is the engine behind this cosmic expansion? The explanation points to the cosmological constant, a force that behaves like an intrinsic tension within the fabric of space-time itself. Albert Einstein first put forth this concept in 1917 to stabilize his equations for what was then believed to be a static universe. When the expansion of the universe was later confirmed, he famously dismissed the constant as his biggest blunder. Yet today, we see that his idea held a far more profound truth than he ever realized. This cosmological constant is now inextricably linked to dark energy, a mysterious phenomenon believed to constitute roughly 70% of the universe's total energy density. To understand dark energy, imagine you are pushing a heavy cart, and an unseen force suddenly begins pushing with you, causing it to accelerate away. Dark energy acts in a similar manner, speeding up the cosmic expansion and propelling galaxies apart at ever-increasing velocities. Yet the reason for its existence remains one of our most significant, unsolved mysteries. One prevailing theory from scientists is that the cosmological constant represents a fundamental quality of space itself, a form of vacuum energy. Within this seeming void, where nothing appears to exist, subtle energy fluctuations can manifest and produce unexpected effects on a grand scale. Consider a glass of water that looks completely still. A closer look might reveal tiny bubbles constantly forming and vanishing. The quantum vacuum might be similarly active, filled with these invisible energy ripples that exert a tangible influence on the cosmos. What does this reveal about our comprehension of the universe? The cosmological constant demands that we rethink our foundational knowledge of gravity and cosmic structure. If dark energy's dominance persists, it has the power to dictate the ultimate destiny of our universe, possibly leading to a future of unending expansion. Scientists are currently grappling with questions of whether this expansion will ever halt or perhaps even reverse itself. Some scenarios, like the Big Rip, propose that if dark energy grows stronger, galaxies will become so isolated they vanish from sight, and eventually, all matter could be torn apart into fundamental particles. But must this be the definitive fate of our universe, or could other, yet-to-be-discovered forces intervene to rewrite this cosmic narrative? The cosmological constant also brings forth profound philosophical inquiries about why dark energy even exists. Is its presence merely an incidental outcome of quantum mechanics, or does it serve a greater purpose? It seems that with each answer we uncover, we are confronted with new, more complex uncertainties, affirming that the universe is a place where every discovery opens a door to further questions. When you reflect on the cosmological constant, you can see a reflection of our own unyielding search for knowledge. It serves as a reminder that despite the remarkable strides we've made in cosmology, a vast ocean of mystery is still waiting to be charted. As our scientific understanding advances, so does our innate curiosity. This prompts us to consider keeping an open mind, as science is fundamentally a journey rather than a final destination. And along the way, we must take time to appreciate the wonders we encounter. The cosmological constant, with all its staggering implications, is but a single component in the grand puzzle of our existence. It's vital to recognize that every unresolved question presents a fresh opportunity to learn, to investigate, and to broaden the horizons of our comprehension. So, whenever you gaze up at the stars, you are reminded that while much remains unknown, each new discovery inches us closer to the truth. The constant's blend of simplicity and complexity shows that the universe will always have more surprises in store, and so long as we continue our inquiry, new insights will light our path forward. Have you ever stopped to consider the ultimate paradox of being? Why reality exists at all, instead of a complete void? This is a question that has captivated thinkers, from philosophers to scientists, for centuries. While the query appears straightforward, its core contains a depth that defies our conventional understanding of the universe. To explore this profound enigma, it helps to picture the cosmos as a great ocean, with galaxies, stars, and planets as islands. The true mystery isn't just the islands, but the ocean itself, the immense somethingness that separates them. Why does this ocean exist, rather than an absolute emptiness? The potential answers could fundamentally reshape our entire perception of existence. And modern physics is beginning to offer some fascinating clues. Within the realm of quantum mechanics, you learn that what we call a vacuum is not genuinely vacant. It is, in fact, a vibrant space teeming with fluctuating energy, where these surges can momentarily spawn particles that vanish as quickly as they appear. This suggests that nothingness is far from static. You might even picture it as a foundational stew from which all of existence could potentially arise. The Big Bang Theory, our explanation for the universe's origin, is central to this conversation. It posits that everything originated from a singularity, a point of unimaginable density and heat. Yet this raises the profound question of what preceded it, prompting you to wonder how such a complex reality could spring from an apparent void. Here, science and philosophy merge, offering no simple conclusions to quench our desire for knowledge. I invite you to pause and contemplate the very essence of being. For anything to exist, it must have some foundation. But the question remains, what or who establishes that foundation? One perspective holds that the universe is merely the outcome of fundamental physical laws at play, while another proposes a more profound purpose that currently eludes our grasp. This pursuit of meaning invariably guides you along pathways that are both scientific and spiritual. Picture every star you see as a unique answer to the riddle of existence, each one a distinct chapter in the universe's grand narrative, with its own story and lifespan. Then, consider the immense darkness between them. Doesn't it serve as a powerful symbol of absence, of all that isn't? You begin to see that existence and nothingness are intertwined, and grasping their relationship is crucial to solving the enigma of our reality. Philosophical thought introduces the compelling notion that perception is a prerequisite for existence, which naturally leads you to ask if reality requires an observer to be real. This line of inquiry suggests the possibility that consciousness is not just a byproduct, but an essential ingredient in the act of creation itself. A number of scientists and thinkers have ventured into this fascinating intersection, proposing that consciousness could be instrumental in bringing reality into being. As you explore these ideas further, you encounter the concept of existence as an emergent quality, much like a powerful storm materializing from the ocean's complex dynamics. Reality, in this view, arises from the intricate interplay of particles and forces, but it begs the question of what sets this cosmic storm in motion. This leads us to cosmology's cosmological constant, an enigmatic energy driving cosmic expansion, which suggests existence is a fluid, evolving process, not a fixed state, turning our inquiry into an investigation of the universe's own dynamic nature. The bizarre and captivating principles of quantum physics compel you to rethink your entire understanding of reality. We see that particles can occupy several states at once, and their actions are altered simply by being observed. This raises a provocative possibility. Could existence itself be contingent on the interplay between consciousness and the cosmos? While this concept is certainly debated, it unlocks countless avenues for considering the active role you might play in shaping your own reality. For centuries, you'll find that diverse spiritual traditions have provided their unique responses to the enigma of existence. Whether it's the Buddhist principle of emptiness or the concept of a divine creator found in monotheistic faiths, these viewpoints encourage you to reflect on the ultimate purpose of reality. They present a fundamental choice. Is the cosmos a deliberate act of divine will, or is it simply a product of random chance? When you venture deeper into the mystery of existence, It's almost impossible not to experience a blend of awe and humility. The sheer scale of the universe, the intricate nature of life, and the profound depths of consciousness all serve as reminders of how much remains unknown. It's plausible that the ultimate question of why anything exists at all will forever lack a conclusive answer. Yet the process of inquiry itself is what drives you to explore, understand, and evolve. In its essence, the quest for truth regarding our existence is a fundamental aspect of what it means to be human. It's an invitation to peer beneath the superficial and immerse yourself in the profound mysteries that envelop us. Along this path, each question you ask opens a portal to fresh concepts and viewpoints, thereby deepening your comprehension of the cosmos. In the end, the most significant element is the curiosity that fuels your journey. Pondering why something exists instead of nothing serves as a constant reminder that the universe is a theater of marvels, a delicate equilibrium of life, consciousness, and enigma. Perhaps your own existence finds its purpose in this very drive to seek answers, revealing that the search for meaning is just as vital as any discovery you might make. Consciousness stands out as one of existence's most captivating and enigmatic phenomena, a subject that has fascinated thinkers, scientists, and inquisitive minds for ages. Essentially, you can understand consciousness as the subjective awareness of being alive. It is the internal monologue you hear, the very thing that enables your experience of joy, sorrow, awe, and the entire spectrum of human emotion. For a moment, consider consciousness as a kind of window through which you observe the world, interpret your environment, and contemplate your own being. But you must ask, what is the origin of this window? Is it simply the product of intricate neural pathways within your brain? Or does it hint at something that extends beyond the purely physical? This inquiry is vital because it pushes you to investigate the deeper relationship between consciousness and the cosmos. Within the scientific community, consciousness is investigated from a number of different angles. One prevalent theory among researchers is that it's an evolutionary byproduct, a sophisticated tool that enhances your ability to adapt to the environment and ultimately ensure your survival. An alternative perspective proposes that consciousness isn't just a biological byproduct, but a foundational element of the universe, perhaps on par with space and time themselves. This raises the question of whether awareness is intricately woven into the cosmic tapestry. The field of quantum mechanics, which has already upended our traditional views of reality, leads some scientists to ask if consciousness influences the behavior of subatomic particles. This fascinating inquiry suggests that your very perception might help determine the nature of reality, meaning that the act of observation could be an act of creation. Now, let's explore the link between consciousness and the cosmos from a more philosophical angle. If your awareness is the very lens through which you perceive existence, how does that affect your comprehension of space and time? Your subjective experience of time's passage can differ dramatically from someone else's. A single moment can feel like an eternity or pass in a flash. It makes you wonder if consciousness actively shapes our perception of time, turning it into something far more personal than a simple metric. We are also compelled to ask if consciousness is an exclusively human trait, or if it exists in other living things. Is it possible that animals have a form of awareness that resembles our own? Looking further out, you can imagine beings on other worlds whose experience of consciousness is completely alien to us. Such questions push us to contemplate the purpose of life and entertain the profound idea that we may not be the only conscious entities in the universe. As our investigation into consciousness deepens, we inevitably confront the subject of memory. The process by which you recall past events and the way those recollections forge your sense of self are central to this puzzle. Memory is often seen as the cornerstone of individual identity, but I ask you to consider a more expansive view. What if consciousness extends beyond your personal history to include a fundamental connection with the entire cosmos? The concept of a shared or collective consciousness appears in numerous cultural and philosophical traditions around the world. This theory suggests that every living thing is part of a universal awareness, an energetic field that binds all life together. If such a reality exists, it would completely reshape our understanding of existence and our role within the universe. It implies that your individual consciousness might simply be a small part of a much larger, interconnected whole. This exploration of consciousness naturally leads to profound questions about death and what might follow. If your awareness is merely a function of your brain's biology, what is its fate after you die? Does it simply cease to exist, or could it persist in some other state? These fundamental uncertainties have inspired a vast array of theories, spanning from the concept of reincarnation to the possibility that consciousness itself is immortal. A number of neuroscientists propose that a deeper comprehension of consciousness could be the very thing that unlocks the universe's greatest secrets. By solving the enigma of the mind, we might finally discover answers to the age-old questions that have perplexed humanity throughout history. It's an incredible thought. Could the key to grasping the nature of the cosmos lie within the study of our own awareness? In this journey, you must also consider how your consciousness molds your perception of reality. Your unique experiences and personal beliefs profoundly affect how you interpret the world around you. This makes you question to what degree your awareness either clarifies or colors your understanding of the universe. It's a line of thought that highlights the mind's incredible power to construct meaning from the apparent chaos of existence. Ultimately, when we talk about the link between consciousness and the universe, you need to recognize that we are all on a path of ongoing discovery. Every solution we find only generates more questions, and each step forward brings us a little closer to knowing ourselves and our place in the cosmos. Consciousness, in all its intricate mystery, represents one of the final great frontiers, and by exploring it, we might learn as much about our own nature as we do about the universe itself. Let's shift our focus to quantum information, an enthralling subject that forces us to examine the fundamental structure of reality. While your daily experience is one of solid, predictable objects, quantum mechanics shows us a world at the subatomic level that is far more bizarre than you might ever have conceived. This brings us to a key question. What exactly is quantum information, and why is it so critical to our comprehension of the universe? To start, you can view information as the data that helps us make sense of and articulate the world. In day-to-day life, this might be as straightforward as noting an apple's presence on a table. In the quantum realm, however, information operates in truly surprising ways. For instance, a single particle can occupy many states at once, a phenomenon known as superposition. Picture a coin that is neither heads nor tails but both at the same time, only settling on one state when you observe it, almost like magic, defying all familiar rules. This leads us to ask how this bizarre quantum behavior is represented as information. The fundamental unit here is the qubit, the quantum counterpart to the classical bit. A standard bit is restricted to being either a 0 or a 1, but a qubit can exist as a blend of both states simultaneously. This unique property empowers quantum computers to handle information in a manner that is fundamentally beyond the reach of conventional machines. Think of it like navigating a maze. A classical computer must try every route sequentially, whereas a quantum computer can investigate many paths at once. This power could transform our approach to solving immense challenges, from designing new medicines to refining complex logistical networks. And it's all deeply connected to another quantum concept called entanglement. This phenomenon arises when two quantum particles develop a mutual dependence, where the state of one instantly shapes the state of the other, no matter how great the distance separating them. Imagine you have two enchanted boxes. This entanglement means that opening one immediately reveals the contents of the other, even if they are light years apart. Such an instantaneous link raises profound questions about the very essence of communication and information. So, what does this imply about your understanding of the cosmos? The field of quantum information hints that the universe might be less a collection of disconnected physical objects and more an intricate network of information. Following this line of thought, some theories even posit that reality is an informational construct, a sort of cosmic hologram, where everything you perceive as matter and energy is, at its core, information arranged in highly complex patterns. Certain scientists have even put forward the idea that quantum information is the fundamental key to figuring out how gravity behaves on a quantum scale. Try to imagine gravity not simply as a force that pulls objects together, but as a direct result of the information and the relationships that connect all particles in the universe. This concept could potentially resolve the paradox of quantum gravity, finally unifying Einstein's general theory of relativity with quantum mechanics. And what is the connection to life and consciousness? Some researchers propose that consciousness itself could be intertwined with how we process and retain quantum information. This potential link opens a floodgate of new inquiries. Is it possible that consciousness is a manifestation of quantum information? Could there be a deep relationship between the structure of the universe and your own subjective perception of what is real? Each of these questions encourages you to reflect on your interaction with the quantum realm and what it means to truly know something. As I delve deeper into this domain, I find that the quest for answers often just uncovers more questions. The nature of quantum information serves as a reminder that knowledge isn't merely the stockpiling of data, but a perpetually evolving and dynamic process. To fully appreciate quantum information, you also have to look at its impact on quantum computing and cryptography. The unique characteristics of qubits allow for the creation of communication systems that are, in principle, impervious to eavesdropping. It's possible that in the near future, you will see the use of quantum networks for transmitting data with absolute security, fundamentally altering the basis of privacy in our digital world. As we continue to investigate these ideas, it's vital for you to acknowledge that quantum information doesn't just contest our understanding of physics. It also poses deep philosophical questions about the fabric of reality. If information truly is the bedrock of the universe's structure, what does that mean for how you perceive time, space, and life itself? Ultimately, the exploration of quantum information is a venture into the great unknown. It challenges you to redefine what you consider knowledge and to remain receptive to new methods of understanding the cosmos. As we advance in this age of discovery, the pursuit of these answers may unlock a more profound comprehension of ourselves and the universe that surrounds you. This grand adventure is only just getting started, and by unraveling the secrets of quantum information, we are drawing closer to the very essence of reality. The expansion of the universe stands as one of the most compelling and enigmatic phenomena that scientists have investigated over the last several decades. But for you to understand what it truly means for the universe to expand, let's first picture the cosmos as a giant balloon. As you inflate the balloon, any small marks drawn on it begin to separate as more air fills the space, which is an excellent analogy for how galaxies are moving away from each other across the vastness of space. The truly interesting part is that they aren't merely drifting apart. They are doing so with increasing velocity. Why would this be occurring? The explanation is tied to a cryptic force known as dark energy. Before I get into that, however, let's pause to consider how the universe's expansion was first discovered. It all began back in the 1920s, when the astronomer Edwin Hubble observed that galaxies are receding from our own. His finding was a monumental breakthrough. If galaxies are moving apart, it logically follows that the universe must be expanding. The mystery only deepened, though, when in 1998, a team of scientists examining supernovae made an astonishing discovery. The universe's expansion is not only ongoing, it is accelerating. So if the universe is expanding at an ever faster rate, you have to ask what power is responsible for this phenomenon. This is precisely where dark energy enters the picture. But what is dark energy? Although you cannot see or measure it directly, it is thought to constitute about 70% of the total energy in the cosmos. It behaves like a kind of anti-gravitational force, compelling galaxies to drift farther and farther apart from one another. Despite its immense significance, we still understand very little about this strange energy. Some scientists have described dark energy as a quality of empty space that permeates the entire universe. But how is it possible for something that is empty to exert such a potent effect? You might visualize it by imagining a classroom where, every time one student sits in a corner, all the other students in the room are pushed away from them. In this scenario, however, that student in the corner generates an effect that makes everyone else move away more rapidly over time. This image helps you grasp the way dark energy might function. A question naturally follows. Will we ever truly figure out what dark energy is? Scientists are diligently working to unravel this mystery, utilizing powerful telescopes and space probes to observe the universe. However, the more we probe the nature of dark energy, the more questions we seem to find instead of answers. Is it possible that dark energy is just a fundamental property of space itself? Or could it be an entirely new form of energy that we haven't yet discovered? I often think of the universe as a vast, unexplored ocean. As you venture into its immense depths, you continually encounter more and more bizarre creatures and mysterious phenomena. Each new discovery simply opens up another frontier of the unknown, waiting to be explored. You might think of dark energy as one of those strange beings that navigates the immense depths of the cosmic sea. As our scientific methods progress, it becomes clear that even with our improved instruments, the universe continues to be a realm brimming with enigmas. A useful way to grasp the accelerating expansion of the universe is to picture a car that is picking up speed. Imagine that a vehicle's engine grows progressively more powerful as it runs. The car would not only travel faster, but its rate of acceleration would also continuously increase. In the grand theater of the cosmos, dark energy appears to function like this engine, not merely shoving galaxies away from each other, but doing so with a force that is always growing stronger. The puzzle becomes even more intricate when you consider that some scientists theorize a connection between dark energy and the cosmological constant, a concept Albert Einstein himself once introduced. Despite this, even the most brilliant minds on the planet remain baffled by the phenomenon. This cosmic riddle is a compelling invitation for us to push our exploration further. Our search for answers demands that we re-examine everything we assume about matter, energy, and the fundamental principles that govern our universe. Along this path toward greater understanding, every fresh discovery seems to generate an even greater number of questions. What will ultimately become of the universe if this accelerated expansion persists? Is there some final limit, or is the universe destined to expand into infinity? Certain theories propose a future where galaxies will eventually recede so far from one another that they vanish from view, leaving behind a cosmos that is profoundly empty and dark. Amidst these uncertainties, some theorists speculate that this acceleration could signal a major transformative phase for the universe. It's possible that as dark energy becomes more dominant, the universe is setting the stage for an entirely new chapter of its existence. The notion that the cosmos is in a state of constant flux fundamentally challenges our view of reality and beckons us to rethink the very foundations of our knowledge. In the end, the accelerating expansion of the universe is a powerful reminder that our comprehension of the cosmos is still in its infancy. Each new finding brings you closer to solving the secrets of dark energy, yet it also exposes just how truly vast and mysterious the universe is. This pursuit of knowledge is more than a scientific mission. It is also a deep reflection on your own place within this cosmic expanse. So, as you continue to look up at the stars and pose these grand questions, remember that each mystery we have yet to solve moves us a little bit nearer to the truth. The accelerating expansion of the universe, driven by the enigma of dark energy, stands as just one of many puzzles that await you in the boundless ocean of what is yet to be known. This exploration is ongoing, and every single discovery is simply the start of a new expedition in our collective quest to make sense of the cosmos. So, what exactly unfolded during the period of cosmic inflation? This is a question that transports you to the most primordial moments of the universe, long before any stars or planets had formed. During this epoch, which lasted for only a minuscule fraction of a second following the Big Bang, the universe underwent a period of exponential growth. But what does that truly imply? Picture a balloon being inflated at an incredible speed. It begins as something tiny and dense, but in a flash, it blows up to a colossal size. This is a good analogy for how the universe expanded during inflation, transforming in a fleeting instant from a point of infinite smallness to a scale you can barely conceive. This expansion was so immense that, to give you a sense of its scale, it would be like taking the entire contents of the observable universe today and compressing them into an object the size of a ping-pong ball. But you may ask, why is this inflationary period so significant? The importance is found in the tiny irregularities that it generated. These minuscule fluctuations in the density of the early universe served as the very seeds from which galaxies, stars, and eventually you would form. Cosmic inflation also provides a solution to a profound puzzle, the remarkable uniformity of the cosmos. When you observe the universe, it appears strikingly homogeneous and isotropic, which means it looks more or less the same in every direction you look. How could this be possible if, under the standard Big Bang model, different regions of space never had enough time to interact and balance out? Inflation elegantly resolves this paradox by taking what was once a small connected region and stretching it across immense cosmic distances, creating the consistent fabric we see today. However, even as inflation answers many cosmic mysteries, it presents you with a host of new and intriguing questions. What, for instance, could have possibly triggered this abrupt and violent expansion? Some scientists propose it might have been set off by an unknown form of energy that dominated the universe in its earliest moments. This energy, frequently called the inflationary field, is central to understanding how everything we see came to be, but we have yet to grasp its true nature. Imagine you are on a high-speed train that is racing through a constantly shifting landscape. One moment you're passing through fields and mountains, and the next you find yourself crossing a vast ocean. This is how the universe transitioned from a singularity into an expansive realm filled with potential. But what about time itself? Throughout the inflationary period, time as you understand it may have behaved very differently. It raises the profound question of whether time even existed before this epoch, leading you to contemplate its fundamental connection to the expansion of the universe. As the cosmos continued to swell, its conditions started to shift. The immense energy of the inflationary field eventually dissipated, which in turn led to the creation of subatomic particles. It was in this new environment that the foundational components of all matter began to take shape. But why was this inflationary phase so incredibly brief? The explanation might be found in the inherent instability of the inflationary field itself. Much like a balloon that can only be inflated for so long before it pops, the universe had to find a state of balance. Scientists have put forth several theories explaining how inflation concluded. Some models suggest the inflationary field settled into a point of equilibrium, while others describe a series of phase transitions in the universe's energy. You can think of this as being similar to how water transforms into steam and then back into ice, passing through different states of energy along the way. It is truly mind-boggling to consider that in its earliest moments, the universe experienced profound transformations which established the very framework for the cosmos you see today. Among the most compelling questions surrounding cosmic inflation is its effect on the arrangement of matter throughout space, as the tiny fluctuations during that era served as the primordial seeds from which galaxies would eventually grow. In that light, every star, planet, and even you are a testament to those first fractions of a second, suggesting you and I share a fundamental connection to the entirety of existence. Investigating cosmic inflation not only allows us to comprehend our cosmic past, but also offers insights into the universe's ultimate fate. Contemporary theories propose that the cosmos may expand forever, but this raises some profound questions for us. If this accelerated expansion continues, what does that imply for our future? And what sort of universe will be inherited by the generations that follow you? It is crucial to note that cosmic inflation remains a highly active field of scientific inquiry. Researchers are currently devising experiments and observations designed to detect faint imprints of this epoch within the cosmic microwave background, the residual radiation from shortly after the Big Bang. Whether they will manage to unlock all the mysteries of inflation is a question that only the passage of time can answer. When you reflect on cosmic inflation, it becomes evident that we are talking about a pivotal chapter in the story of the universe. Every breakthrough in this area draws us nearer to a true understanding of our own origins and, quite possibly, our destiny. More than just an astronomical event, inflation serves as an invitation for you to contemplate deeper inquiries into reality, the nature of time, and the very fabric of being, reminding us that in the quest for knowledge, the questions you ask are just as vital as the answers you find. Our innate human curiosity perpetually propels us ahead, where each solution we uncover seems to unlock even more pathways into the enigmas of the cosmos. The essential nature of reality is a subject that frequently prompts deep contemplation. As you and I venture into the universe and its secrets, a compelling question emerges. What truly constitutes reality? For most people, reality is defined by what you can perceive with your senses, a tangible world that feels solid and dependable. But what if the truth is far more complex than it seems, and everything you believe to be knowledge is merely a sliver of a much larger picture? Some scientists propose that what you call reality could be a form of elaborate illusion. You might envision a video game with graphics so lifelike that you can no longer tell the virtual from the real. In this context, our reality could be akin to a sophisticated computer program, governed by rules that are entirely different from those you experience in daily life. The idea that you could be living inside a simulation, while sounding like science fiction, is a concept that has been seriously explored by thinkers like the philosopher Nick Bostrom. Quantum physics also presents us with a radically new framework for understanding reality. On a subatomic scale, particles are capable of existing in multiple states at once, a principle referred to as superposition. This introduces a fascinating possibility. What if reality itself is composed of countless potential outcomes that only solidify into one when you observe them? In other words, could your own attention and consciousness be playing a direct part in the very creation of reality? Time represents another dimension of this puzzle that is worth considering. In your everyday experience, you perceive time as a linear progression from past to present and into the future. Yet, certain scientific theories suggest time might not be linear at all. Imagine if time were more like a vast ocean, where every moment coexists simultaneously. This notion forces you to reconsider how you perceive the flow of time, and whether you have any genuine control over your journey through it. Einstein's theory of relativity also fundamentally alters our grasp of reality. His theory describes space and time as being woven together into a single continuum known as space-time. This suggests that events are not isolated by time in the way you might assume, but are instead linked in ways we are only beginning to comprehend. How does this reframe your perception of reality? It hints that the universe may be threaded with invisible connections that actively shape your experience. As we delve deeper into the nature of reality, you inevitably confront the influence of consciousness itself. Your consciousness is an intensely personal and subjective experience. But what is it, fundamentally? Some scientists theorize that it is an emergent property of neural activity in the brain, whereas others speculate it could be a much broader phenomenon that links all living things. Is it possible that your consciousness is part of a greater network that extends beyond your individual self? Exploring reality also compels us to examine the role of your perception. Each of us interprets the world in a unique way, colored by our personal history, cultural background, and emotional state. What if your perception is not an accurate depiction of the external world, but is instead a projection of your own mind? This leads you to question whether an objective reality even exists, or if each person inhabits their own distinct, personalized universe. Another facet to consider is the relationship between reality and matter. The question of whether matter forms the basis of reality has been a central debate from ancient philosophy to modern physics. Some propose that matter is simply a manifestation of something more elemental, such as pure energy or even consciousness itself. Could it be that reality is a tapestry of interconnected energy, with matter and consciousness being just two of the threads woven into its intricate design? Furthermore, questioning the nature of reality invites you to meditate on existence itself. Why is there something instead of nothing at all? This profound philosophical query has captivated thinkers for centuries. While science seeks to provide answers through cosmological models, the ultimate explanation may forever lie just beyond our grasp. Are you and I part of a cosmic accident? Or is there a deeper meaning behind everything you observe? As you explore these ideas, it's perfectly natural to feel a sense of awe at the sheer complexity of reality. Yet, it is this very intricacy that makes the subject so endlessly captivating. Every discovery you make leads to new questions, guiding us toward a more profound understanding of ourselves and our place in the universe. The pursuit of what is real is a perpetual voyage filled with astonishing discoveries and profound insights. Ultimately, the very essence of reality emerges from the dynamic interplay between the cosmos and our own consciousness. In this immense ocean of possibilities, every one of us acts as an explorer, attempting to find solutions to questions that often feel just beyond our reach. Imagine if a theory of everything existed, a single, elegant framework capable of explaining every phenomenon in the cosmos. The pursuit of such a theory can be compared to assembling a celestial jigsaw puzzle, where each piece signifies a different aspect of reality. The trouble is, many of these pieces stubbornly refuse to connect with one another. Take gravity, for instance, a force we have understood for centuries, which operates in a completely different manner from all the others. Whereas gravity dictates the motion of massive objects like planets and galaxies, nuclear forces command the interactions of subatomic particles. The core challenge, then, is understanding why it is so profoundly difficult to make these two fundamental pieces of reality fit together. Over the years, scientists have put forward numerous potential solutions, with string theory being among the most well-known. This theory suggests you should picture subatomic particles not as infinitesimal points, but as vibrating filaments of energy, with each one producing a unique resonance. A particular particle is defined by the way its string vibrates, and its characteristics are determined by the frequency of that vibration. But this captivating concept introduces its own set of perplexing questions about unseen dimensions. Let's now consider the field of quantum gravity, which attempts to merge two pillars of modern physics: Einstein's general theory of relativity, our description of gravity, and quantum mechanics, which presides over the subatomic realm. The difficulty here is immense, much like trying to get oil and water to mix. Scientists find themselves in a similar situation when trying to reconcile these two frameworks, as gravity seems to occupy a world of its own, resisting every effort at unification. Humanity has certainly experienced moments of profound insight throughout its history, such as the paradigm shift in our comprehension of space and time brought about by Einstein's theory of relativity. Yet, despite these monumental achievements, the quest for a theory of everything continues to be a journey fraught with immense challenges. The primary obstacle holding us back might just be the sheer, inherent complexity of the universe itself. Researchers are not confining their search for answers to theoretical models. They are also turning their gaze to the cosmos. Clues about the universe's fundamental nature have been gathered from observing distant galaxies and analyzing the cosmic microwave background, which is essentially the residual heat from the Big Bang. Nevertheless, even with these observations, we are confronted by the enormous puzzle of dark matter and dark energy, prompting us to wonder if these unseen influences could be the very link that connects all the forces. Picture yourself discovering a vast, ancient library in a city you've never visited before. Inside, the shelves are packed with volumes containing boundless knowledge, but the majority are written in a language you simply cannot read. This is a fitting analogy for how the scientific community feels when facing the deep enigmas of the cosmos. An incredible amount of information is waiting to be uncovered, yet the language of nature remains intricate and mysterious. A theory of everything extends beyond simply unifying physical forces. It also compels a deep examination of the universe's purpose. It forces us to confront the age-old philosophical question: why does anything exist at all? A complete theory could potentially provide insights not only into scientific mysteries, but also into the very nature of our own existence, pushing the boundaries of what we thought was possible to understand. In this great pursuit, scientists are much like mariners navigating uncharted waters. Every new theory is a vessel embarking on a voyage into the unknown. While some may founder, others occasionally discover entirely new continents of knowledge. This raises the question of whether there are ultimate limits to what we can know. But even if some questions remain perpetually out of reach, our innate human curiosity ensures that the search will never cease. The scientific community is also grappling with a very real, practical hurdle: the necessity of collaboration. The hunt for a theory of everything is far too vast for any single individual. It demands a cooperative effort, blending the expertise of physicists, mathematicians, and philosophers. In our current era of technology and global information sharing, this kind of teamwork is more crucial than it has ever been to decipher the universe's secrets. As we advance along this path, it is vital to recognize that each new insight is merely one step on a seemingly endless staircase of discovery. The quest for a unified theory compels you to question not just the cosmos, but also your own place within it. The ultimate challenge might be our readiness to face answers that are even more bewildering than the questions that prompted them, as this journey is as much about self-discovery as it is about scientific truth. The distant stars glittering in the night sky serve as a constant reminder that our desire to comprehend the universe is a fundamental part of what makes us human, even when the way forward is unclear. The search for cosmic answers is an immense puzzle, with countless disconnected pieces. And as you delve into its mysteries, you encounter questions that both test our scientific models and ignite a profound sense of wonder. It's truly staggering to contemplate the sheer immensity of the universe, where every star, galaxy, and patch of darkness is laden with secrets. Our scientific voyage has led us to concepts that sound as if they were drawn from science fiction. From dark matter, which constitutes a huge fraction of the cosmos, to dark energy, the force accelerating the universe's expansion. All of this complexity, from the vast clusters of galaxies down to the smallest particle, forces you to ask, what does it all mean? And how does it shape our understanding of reality and our role within it? When you contemplate these cosmic wonders, it's natural to question how they originated and what they reveal about the universe's long history. Thinking about this is much like examining an ancient chart, trying to piece together how the continents found their forms. Every line and every contour tells a part of a story that we are still working to fully understand. Quantum gravity presents another of these profound challenges, one that compels you to question the fabric of reality itself. Consider two forces, quantum mechanics and gravity, that are essential to our cosmic model but operate by irreconcilable rules. They are like two protagonists in a narrative who can never interact. What new truths might we uncover if we could finally harmonize their principles? In this pursuit of understanding, you can't help but speculate about life in distant corners of the cosmos. The notion that we might not be alone is a powerful theme that has long inspired scientists and dreamers alike. It makes you wonder what forms such life might take, and how we could possibly detect it. The search for extraterrestrial intelligence is more than just a scientific goal. It reflects our own deep-seated curiosity and our yearning for connection. Time, that famously elusive concept, also invites deep reflection. Does it truly flow forward in a linear fashion, like an endless stream, or is its nature far more complex? This question pushes you to examine your own existence and your personal perception of its passage, leading to the radical idea that time might simply be a construct of our own minds. As you explore the chronicle of the universe, the Big Bang Theory offers a captivating starting point. But the ultimate mystery remains. What came before that explosive beginning? This question forces us to think beyond our known limits and to imagine a state of existence completely different from our own. This very type of speculation is the fuel that drives scientists to keep searching and dreaming. The idea of a multiverse is even more mind-bending, suggesting our universe could be just one among countless others, each with its own physical laws and realities. This concept doesn't just challenge our view of existence, it also encourages you to consider the philosophical weight of our own place within it. How does the knowledge that we may be part of an infinitely larger structure affect our perspective? Black holes, those great cosmic enigmas, serve as a stark reminder of our limited knowledge, especially concerning what lies within them. Current theories speculate they could be gateways to other locations, or perhaps even other dimensions. But trying to truly grasp what that implies is a monumental challenge. Each question we pose about them only seems to generate more, perpetuating an endless cycle of inquiry. Then you have the cosmological constant, which, despite seeming abstract, is crucial for understanding the universe's evolution. Why does this value exist, and what is its precise role in driving cosmic expansion? Every new insight in this area refines our understanding of cosmic behavior, while simultaneously presenting new puzzles that force us to reconsider what we thought we knew. Perhaps one of the most profound philosophical questions you can ask is why there is something rather than nothing at all. This inquiry leads you beyond the boundaries of science and deep into the territory of philosophy. You have to wonder if existence itself is merely a statistical accident, or if there is some underlying purpose behind it. Our own consciousness adds another layer to this mystery. What is our function within this immense universe? And how does our personal, subjective experience connect to the objective reality all around us? This is a domain that challenges both scientific and philosophical thought, where every attempt at an answer simply opens up new avenues of exploration. Quantum information, while it might sound like a highly technical and remote field, is actually fundamental to how the universe operates at its most basic level. What is the true nature of information in a quantum context? The answer to this question holds profound implications for how you perceive reality and your interaction with it. Everything I've mentioned today represents just a fraction of the immense network of questions that define our universe. Each discovery we make seems to unlock doors to new inquiries and an infinite spectrum of possibilities. The universe's accelerated expansion, the theory of cosmic inflation, and the ongoing search for a unified theory all remind us that there is so much more left to find. As we conclude this part of our journey, it's vital to remember that every unanswered question is an invitation to continue observing, to keep probing, and to never stop wondering. Science and curiosity are the powerful engines propelling our quest to comprehend the cosmos. And while we may never find answers to some questions, the pursuit of knowledge is itself a magnificent adventure. In this grand endeavor, every single one of you has a part to play, a spark of curiosity that can ignite fresh ideas and lead to new discoveries. You should never underestimate the power of asking a question. At its heart, every inquiry is the first step toward a new and undiscovered horizon of knowledge.